good evening, good morning via Europe to everybody. And thanks for having me. I hope that everybody of you are safe and healthy. This is really an unprecedented time, and we are doing this one in a virtual way, which is good to keep our community connected and engaged. The title of the presentation is pretty long, so I just summarize as automation in the autonomous network. Let's go to the next slide. Quickly, legal statement, not really interesting. Let's enter into the agenda. So before going into the details, just to give you a little bit of the thought process, I will talk about the automation and the autonomous network and how this concept will be applied to the real deployment. And within this concept, we will explore the paradigm of the automatic network. That is the engineering toolbox that we have to develop in a concept of autonomous network. And therefore, one of the key components that is the autonomous SDN. So the first part of the presentation, we'll talk about this one. Some of the key aspects in terms of openness, automation, and simplification, and we'll see how they do fit into this bill. Some practical implementation to show that effectively, not only it makes sense, but there are a lot of benefits by embracing this type of architecture, and then conclusion. In this journey, I will go a little bit on a long road, but bear with me for a little bit. And if you think about in the human experience, on the human stories, the successful technology or engineering solution are those ones that solve practical problems efficiently, do more with less, in a reliable way, resiliently, so no failure or very little, and fundamentally scalable, so can be transferred and reproduced. And if you go a little bit further and you think about the automation and the system controls, is fundamentally the engineering theory in practice on how to control the behavior of this system in feedbacks and closed loop. And this is one of the first key elements or aspect that we need to consider in this journey. And however, when you go to the automation and the autonomous network concept, it's my belief that you are dealing with the engineering problem of operation automation, and therefore with the software problem that is underlying this type of solution. And so through this thought process, if you think a little bit more further, the engineering toolbox that is the automatic network is fundamentally the solution to the automation operation automation, and solving this problem via the software automation. And fundamentally, there will be great benefit at the first instance for both the development and the operational team. That where this benefit will apply, and then they can be transferred directly to the customer and the end user. So the concept of software automation and then the organization that sits behind it, that is DevOps, will be focusing and spend less time on repetitive, time-consuming tail tasks, and more on what is the project excellence, what is the project enhancement and innovation that can be immediately seen and be made available and visible to customer as experience and quality of what they do. However, before we go further, there is a little disclaimer. When we speak about autonomous network, we need to make sure that we don't understand where they will be consumed. And fundamentally, what are the conditions in the ecosystem they will operate? And if you think about a typical data center, whether it's a cloud, public cloud data center, whether it's a private cloud data center, it's a very stable, predictable, and uniform environment. While if you try to develop and deploy this type of a concept into the asset, into the edge, and we will see some examples, you have to deal with an environment that is typically unpredictable, variable, non-homogeneous. And so when you look at the automatic network and fundamentally the building block that has to deal with this problem, which is an SDN controller, an autonomous SDN controller, what is the objective that you needed to accomplish to make it working? Fundamentally, the problem that you have to solve is how to solve the equation of the desired network, so what you have planned, what you have designed, with the current network, what you observe, you measure, you operate. And so the autonomous SDN is the toolbox that you develop in order to equal these two parts of the problem and to make this an equation. And so fundamentally, in this thought process, we come to the definition of an autonomous SDN network. That is the toolbox that can translate the desire into an intent, and therefore transform this intent into resources and objects that it can schedule, execute, and then feedback whether there is a success, failure, health, performance to the cycle of the life of the network in order to close the loop and work into a workflow that is a closed loop, and therefore reinstall the new intents if they are not fulfilled. And this is the concept of a closed workflow. So the paradigm of an autonomous SDN is effectively, in few words, you see the network, you know the network, and then you operate, do things on the network. Which brings us to the last slide. And what is the blueprint of an autonomous SDN network in the paradigm of the automatic network? You fundamentally need to see the network as a fleet, not as just a composition of a component node port. And you need to see with the eyes of the abstraction into the model, into the characteristics, into the definition of what are the states of the network. And you need to be able to collect the data that you can extract from the network, store, catalog, and therefore analyze to extract what is the value of these gold. And then you move to the next, that is fundamentally create the knowledge and the know-how of the network, where you can understand what are the behavior of the network, what are the patterns of the network, and by the analysis of the data and the help of AI-driven application, you can create scenario of what if that can help you to predict what will be the future behavior, because you don't want to have a network that is reactive, and we will see why, but you want to have a network that is predictable. And so you create insights of the network. You can look at the insurance, trust, health of the network. And then you come to the last part, which is the execution, the operation, where the autonomous SDN create the tasks that the intent commanded to him, and then execute these tasks into a complete closed loop for the entire end-to-end life cycle of the network. And so you have the intent reconciliation, and you have the remediation and deprecation if an application or a service is not working. So this is the thought process that is on the background when you look at and think about the concept of automatic network and autonomous SDN. And so let's look a little bit more what does it mean from this perspective. Really, I'm trying to distill in few words so to make sure that we have some concept that will receive you when we finish this conversation. And this is about openness, automation, and the simplification. What does it mean? Well, before we go into the next slide, I want to make sure that I'm not proposing to throw away the network and build another network. That's not possible for several reasons. We need to transform the network, and I will show you examples. So to make sure that we can make networking better, we can use the resources in a more efficient way, in a more elastic way. We can program what we have today to make the networking better. And this is the problem we're trying to solve. If you remember the first slide, I proposed a temporal axis to describe how the different architecture of the network and the solution have evolved in time. This is the same axis, but with the business logic, if you wish. And the critical aspect we needed to understand is that the value proposition has shifted now to the service experience. Customers are not anymore interested in the old way to see the problem. They want to control their service experience. That is the money. That is the value. There where they can differentiate themselves. And fundamentally, it's clear that if that is the objective, the software and the automation of software, the life cycle of the network, the DevOps, and the automation and the AI-driven operation are the critical aspects that we need to consider to make sure that at the end we can shift from focusing on how the network operates and how the service operates. What is the quality of the services? And they want to go back to the point where it's important the customer confidence. And an example, if you are flying on an airplane, you're not interested in how fast the airplane is going. You're not interested on all the whistle and needle that make the airplane flying. What the operator of the airplane give you is the experience, is trust, is assurance, is a security on the service. Well, that is all about also today and next generation network. So the customer experience and the service experience are the key driving factor. We had a survey, unfortunately, it's in 2019, 2020, has been a little bit a challenge for all of us to stay connected, have this sort of panel, but we did a panel with with some of the largest service provider in 2019, and a lot of feedback came out from that conversation. And fundamentally, what they have told us is openness, automation, and simplification. The network has to be open because at any point in time, they want to insert new technology, new application, new solution, and not be blocked by the cycle of the network. So network has to be open to accept. And they want to do in a seamless flow via automation of integration, automation of delivery, automation of deployment. They want to experience the capability that is typical of cloud application. And the simplification is the aspect that they really do care because they want to consume the network as it's always and anytime connected to a cloud experience. DevOps has to conceive with automation and AI type of concept, and also the cockpit where they do see it has to be simplified. Think about the cockpit of the shuttle, and we have seen a few months ago the cockpit of the new SpaceX, and you can think about what is the end game. And so we can go very quickly to a practical example, and we have to go in circle because at the end, automation without efficiency is a nightmare. But at the end, the simplification of the automation will bring the ultimate sophistication. And so it's really going into a circle. And that's why I like these two sentences, which bring me to the first example, how to build these automatic network and autonomous SDN. It's all about the software architecture. It's all about how do you layer your software in order to create common cloud native infrastructure. This is the key word. You have to containerize your software, create a microservices architecture that enable you to atomize your solution and keep in control and scale. Kubernetes orchestration is the future of Cloud Net OS. It's a definition that may have a challenge, but it's where you need to think about the Kubernetes, and you have to create elastic, scalable, programmable, and high availability infrastructure. Because then when you can sit your services and applications, and this infrastructure layer will provide you the lifecycle management of all your applications that are above and beyond. And think about that is all about abstraction of the complexity that arrive from the underlay layers to the above layer, in order that what you needed to consume is the model, is the behavior, is the characteristic. You don't want to deal with the technology with the supplier and so forth. And then, of course, you have to create a scalable and flexible platform. Here, the very important aspect is decoupling of services via abstraction model. So you don't want to deal with the differences, but you want to deal with the common model. The intent workflow is now the operational system that will orchestrate, as we have seen, what you do rather than how. Share telemetry analytics, so you have a data lake that will give you a single point of view of all these 1,000 eyes, and role-based access control, which will define how do you interact with the network behavior. And here is the first example, very quickly, from one of the large service providers. They had to make a transition of their voice over IP network that was going in obsolescence, and so the cost of maintaining that network were very large. And so what they thought is this telco cloud transformation, where they identified a very clear objective on how to transform their traditional central office into a data center and into a data center architecture. So they said, we want to have a single inventory. We don't want to deal with multiple pages of Excel files with the different inventory. One single place for inventory. Continuous integration and continuous deployment or delivery, in order that the automation will drive the flow of new services and applications without never stopping the operation of the network. Common monitoring and alarm, so you can see the network from the data model, you can see the network from the behavior. Virtualization of all the infrastructure and services, so you don't deal with the different technology, different supplier, but you deal with the virtualized aspect that is what you're interested in, and a common UI and reporting part. And they call this one automated OSS platform. And here on the right side, you can see how we have layered the different software structure, and how this software structure from the bottom to the up provide a layer of abstraction and layer of normalization, where you can take the different network element, network function, network virtualization function, application, or the different infrastructure, you virtualize, normalize, and then you send into the middle layer that is the common data lakes, where all the monitoring, tracing, logging, alarm are stored, organized, and then they are made available to the application layer. And so the application layer, that is where you experience the service, doesn't have any clue whether it arrived from a box from vendor A or a box from vendor B, is a part of this node, that node. You all see the network as a fleet into an holistic view. And you can have a dashboard, you can have a time scale analysis for forensic analysis, for definition of performances, closed loop remediation, you can expose to a cockpit GUI, or you can have into a complete visualized dashboard on your app. So that is the complete transformation. And the last slide, and then I will go to the conclusion, is a very complicated slide. We're not going to enter into the details, but again, is the application of the cloud experience to the network. And the 5G network will exactly operate after the disaggregation of specifically into the edge cloud part of the network, the disaggregation of the different elements of a RAN into unit, the radio unit, the distribution unit, the central unit, that now are completely disaggregated. You can appreciate the visualization of a data center architecture sitting behind, and the virtualization and the softwareization of all the layer above and beyond to provide continuous abstraction of the different elements in order that the application can consume data model, service model, common telemetry, common monitoring, and the closed loop functionality that will be provided by this layer that will cover now the end-to-end network. And this is the visualization of the concept of an autonomous network, is the visualization of how you automate your operation and how you create the value and the experience from a service perspective. And so, since I'm running out of time, just a few conclusions. Automation stay to the simplicity. So the two things have to come together. If you automate, you don't simplify, you're not doing a good job. The autonomous network is fundamentally the connection to a cloud experience. You need to think about a cloud and native architecture. You need to think about how to create and automate layer of software, and how this layer of software will abstract and provide the value up to the above layer. And the intent layer is the critical part for creating a closed loop workflow for the new generation of SDN or autonomous SDN. And the few examples I've made, a telco cloud transformation of a traditional central office into a telco cloud data center, and the end-to-end 5G network solution with the disaggregation, virtualization, and softwareization toward the application are two critical examples, or clear examples on where is this transformation going. And with this one, I thank you, and I really appreciate your time.
Thank you very much. Well done on the timing, and very provocative and interesting presentation. One quick question. I really like that slide, the see, know, and do slide that you showed. However, the question about seeing, you're talking about transforming both the traditional network and how it operates, and moving to more understanding the customer experience and the service, which means that the C that you have must change over time. Am I thinking about that correctly? Meaning that initially you have information about the network itself, but you need to transform that so that it tells you how the customer is actually experiencing their service on the network. And the second challenge associated with that is that it needs to be open, meaning that multiple vendors need to use similar approaches or technologies to support this transformation. And so I'm struggling with those two concepts.
Well, it's a valid question, and it's one of the key challenges and the problems that we do have. And I just go back to the slide, because at the end, this is exactly one of the problems that we have solved. You know, how do you see the network? And you see the network in a way that you can always add new eyes to your network, whatever these eyes are. And how then you make sure that when you have the visibility, you have a uniform way to watch the network. And if you look to this architecture, fundamentally, these two blocks, the NFV-I and the NE-NFV, this is the network. These here are all the different boxes, switch, router, server, optical box, whatever it is. And there is a layer here, and these are the infrastructure. So all the building blocks that provide you the operation of the network, operating system, software stack, routing protocol, and so forth. And so fundamentally, what you do is you normalize all these point of entrance into this virtualized layer that you don't control. This is part of the first layer of architecture, that is the so-called underlay. You normalize in order that you create a flow of the different now definition of what you see into the network, whether it's alarm and events, whether it's the metrics, logging, tracing, telemetry, and so forth. And so you create a place where you start to deposit all these different aspects, that is the eyes of the network. And at that point, you are now in a position where you have a bunch of data that are arriving from all the different angles of the network. And what you do now? Today, what we do, we just show to the customer everything. You know, they have this huge cockpit, you can imagine, with all these different visualization, and they need to understand whether the alarm is important to them, and whether this alarm is because a logging fail, or because the configuration fail, or whatever. What we have done is the creation of this common monitoring infrastructure in the middle, where first and foremost you create via a Kafka bus a broker where all this data started to travel. It's like a huge highway where you started to flag all these elements to say you are an alarm and you happen at this time, you come from this node, and this is what you are. And you started to create this flow of data into this Kafka bus, and therefore you started to broker and move this data into different databases for different type of queries. And at that point, when you have created this layer, adding another box is just adding another car on the highway. You're not going to change anymore the highway. You have just to make sure that the highway has enough capacity. And at that point, from the monitoring application now, it's not anymore about the full visibility, because that is the infrastructure visibility, but it's the intent that will translate and give you what is effectively the data that you need to attach to your application, to your AI, to your dashboard, to have an holistic view, but a service view of what is happening in the network. Yeah. You consume what you need. You don't consume everything one time, all at the same time.
Yeah, no, thank you. That's very good. And this also is very good, because now you have both a common monitoring infrastructure and which may be surface focused, but that's okay. You could have AI here, and then you have a monitoring applications, which now you understand what about the infrastructure impacts the application, impacts the service. Very good.
Exactly, and these are cloud-based architecture, so you can run on-prem, you can run in a cloud, you can scale elastically, you can have a geo-redundancy, so you can have a Kafka bus that is deployed in San Francisco and in Tokyo, but from a customer perspective is the same infrastructure. It's not a different infrastructure. Then you need to reconcile, stitch together, push together, and then say, oh, now I understand what's happening, maybe not.
Thank you very much. Well done. Thank you. Appreciate that.
Okay. Thank you.